Okay, so let's do a couple more strange ones with the like with these exponents. So we want to get to just a nice number. So this is 17 does not go into 20 evenly. So 17 times 2 is 34. So I'm going to shoot for that. So what I want over here is x to the 34th power. And when I do that, 17 goes into 34 2 times, so I'm going to get an x squared. So I get rid of that root in the denominator. So if I bump this up to 34, it's going to be, it's going to be the 17th root of 34 minus 20. So it's going to be x to the 14th power. So that's what I'm going to multiply both the top and bottom by. And so I end up getting, for my final answer, I'll do this another color, the 17th root of x to the 14th over x squared. And I know this does not look simplified. Like that kind of stresses some people out. It's like they feel like they need to combine these two, but if you do, then you're just going to end up with a square root in the denominator. So your goal is to ask yourself, do I have, not a square root, but any kind of root in the denominator? So do I have a root in the denominator? No. Can I simplify this anymore? I really can't, so I'm done. Okay, so this one here, see if you can kind of wrap your mind around it, and then we'll go over it together. Okay, so on both of these problems, you could simplify them, like 4 goes into 17. What would that be? 4 times with the one left over. That's totally okay. You can do that. I don't like to do it that way. I just try to see, okay, what is the nearest thing that 4 can go into evenly? And so that's going to be 20. So like my goal is, is going to be the 4th root of x to the 20th, because that is going to give me x to the 5th, and then I can simplify it as we go along. Okay, so if my goal is x to the 20th and I have x to the 17th, then I'm going to multiply by the 4th root of x to the 3rd, both the top and bottom. Okay, so when we do that, we're going to get x squared times the 4th root of x to the 3rd over, and then it's going to be x to the 5th on bottom right here. Remember, it became that. And so now I can simplify it. So I have the 4th root of x to the 3rd over x to the 3rd. And again, this is another one where I feel like, I need to simplify this, but there's really nothing to do here. Okay, so now we're going to rationalize when you have binomials, so like 2 terms. Remember, you have to use that conjugate. And so what a conjugate is, it's that special thing that you guys talked about in Algebra 2, where you, when you multiply it together, the middle terms cancel out. So let me show you. So this is the conjugate of this. So notice the only thing that's different is the minus sign. So when you multiply these together, and we've talked about this before in this class too, let's just do, so we have first 1, outer, that's going to be positive square root of 3, inner, negative square root of 3, and last is this, negative 3. So if you'll notice, what happens is these cancel out, and I get 1 minus 3 is negative 2. So that's why conjugates are our friends, because they always end up without a square root in the denominator. So let's kind of clean this up a little bit. And okay, so our conjugate is this. And remember, I'm just going to focus on this. This is 1 minus square root of 3 times square root of 3 is 3. And then don't forget, you're going to distribute that 4. So I have 4 minus 4 square root of 3. So let's kind of clean this up a little bit more. And don't forget, you can take this further. So that is going to be negative 2 And then we have -4 over -2, which is a +2 square root of 3. Okay, so this one is the exact same way. See if you can do that, and then we'll go for it. Okay, so I multiply this by the conjugate, and I got 5 minus square root of 3 on top. And then on bottom, I got over 22. And so that is my final answer. And on these, you can simplify this even further if you want to. You don't have to, but sometimes you'll see it look like this. So either one of these is going to be okay. And that's